And of course, make sure that we are actually recording the right channel from the audio portion. It looks like it's recording from the correct channel. And you mentioned it was a little bit soft.
Yeah, it looked like it had turned down before.
I can bump it up a little bit. Here we go. All right. Okay, if you come in late, you can pick up your exam a little bit later, so that way we don't have a lot of disturbances. Okay, so what we will do today is to continue the discussion of subroutines, particularly how to return values. The homework assignment is finally fixed because I forgot to do it on Thursday, and then I was away the weekend. Normally I have access from home to my office computer. For some reason it was not working over the weekend, so it took me a little bit of time to work on it. So this is your homework, and you have 1 week from today to turn it in. So I still give you 1 week to work on this homework assignment. And we'll just go ahead and take a quick look at it. I won't talk about the solution, obviously, but I'll just kind of point out what the algorithm looks like, so that you can take a look at the algorithm. And well, it's not really that bad. I mean, this one does not have recursion, and it does not even have return values. Okay, it has pass by reference. You can see that in subroutine sub 1, it has passing by reference. X and Y are passed by reference parameters, local variable t, and then you have this, familiar sequence of assignment operations. And then sub 2 has one pass by reference, one pass by value, and a local variable. The local variable is updated inside the subroutine, and then we invoke the other subroutine using x and t. X is passed by reference to me, t is a local variable. And then we have subroutine S3, the last one. And in this one, we have a single local variable I. It is initialized. And then I use the same thing to specify both parameter x, as well as use it as a part of the expression to specify parameter y when I invoke S2. And that's it. The main program, the portion that is outside of any definition of any subroutine, is only going to invoke S3. Okay? So it does not have return values, and return values can be a little bit more confusing. So this one, I think it's not too difficult. There are no loops. So this is definitely not busy work. You don't have to loop through something 200 times. There are no conditions to evaluate. It's basically just a straight shot. It's all about how do you set up the parameters, how do you set up the local variables, and whether you remember how to clean up the columns after a subroutine is done. So it's all about that, and I don't think it is too difficult. If you want to track down the number of lines in the trace, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, maybe around 16, between 16 and 18. Okay. So it's not a long trace. It's all about whether you can demonstrate your understanding of the concepts. Any questions about this homework assignment?
What are the double directional arrows again?
The double directional arrows, you mean here?
Yeah.
We only use it when we are passing by reference, so that we know that whatever is on the left-hand side will be changed when you make changes to whatever is on the right-hand side. They are basically equivalent. Look at the double-sided arrow as a wormhole. Yep. You make changes to one, it affects the other one.
Locals.
Any questions? Yep.
For locals, is that just for like that one subroutine?
Local variables are always local to a subroutine.
Okay, so
Yep.
so it deallocates when it ends, right?
Yes.
Okay.
In this homework assignment, there are no global variables. Everything that you allocate will be on a per invocation basis.
I mixed it up. Local and global, I mixed up the word.
Global means everybody can see it, so it has to exist before you get into a subroutine. Local variables only start to exist when a subroutine is invoked, and it disappears or it just evaporates as soon as the subroutine is done. So that's why local variables are called per invocation resources. When you invoke, it starts to exist, but when you get out of the invocation, when you return, it disappears. Okay. Yep.
C++ is offered in summer also.
C++ and
The class, like 3 to 6.
Is it offered in the summer?
Yeah, the one that I tried to, it's gone. Like,
Which one?
By the time the 4th day, there's no classes open. There's.
No, I'm just wondering, like in general, if it's offered in summer.
you mean C++?
Yeah, the class.
The class?
It only online.
Unfortunately, that is a trend for all of our classes now. Many people do not even have a chance to sign up. Like yourself, as soon as it is your turn to sign up for a class, it disappears. And that's because we just don't have the FTEs to offer the classes. One thing you can do is to approach the instructor and ask the instructor, do you mind if I stay in the class until there's an opening, like many of you did with this class? With a C++ class, it is not atypical that maybe 20–30% of the students will drop at some point. The only question is, when will that spot be open, and can you hold on for that long? Do you have other classes that you might want to get in that has the same time slot? But I would definitely approach the instructor and ask the instructor, do you mind if I stay in the class, do all the homework, take all the tests until an opening is open? And you have to understand sometimes such an opening may not even open, even though in most cases the opening will open. Some professors may not take it. Some professors will tell you, the class is full, it is closed, and you cannot even sit in during that time. So it all depends on the instructor. Some instructors let people do it, and some instructors do not. Okay. Any other questions? That's a good question, because this will happen, unfortunately, for the next at least few years until we have the budget back on track. And who knows when that will happen. Yep.
About the C++, when you do that class, is it just like you actually on the computer, or are you on the paper?
Okay, the question is, when you take the C++ class, how is that class, taught? That class has a lab unit. This class has 3 lecture units and no lab units. The C++ class has 3 lecture units plus 1 lab unit, which means, you will have time to spend in the lab with the instructor, and you will be actually writing programs in C++. In that class, there won't be any traces. There won't be any assignments like this where you have to trace a program by hand, and you won't even be given an algorithm. Instead, what the instructor will give you is a sheet of paper to describe what a program is supposed to do. It can be a puzzle to solve. Okay, it can be a crossword puzzle. It can be some other stuff that you have to solve, maybe a sorting type of thing. But you are responsible to actually write the program in C++ and make sure the program works. So the professor will be grading your assignment, basically your program, based on whether it works, as advertised, as described by the homework description. So it's quite the opposite of what we usually do in this class. In this class, I design the algorithm. I give you code to trace, and all you have to do is to understand when the computer sees this kind of statement, this is the behavior of that statement. That's the focus of this class. But in C++, it is opposite, where the instructor will just tell you, I want you to write a program that will do blah, 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 and that's all written in English. So there's no pseudocode even given to you. So you have to come up with the logic and also implement it in C++ at the same time. So now you have 2 things that you have to be concerned about. One is the actual logic, which we deal with kind of in this class using pseudocode. And the second thing is the syntax of the program, because you have to know when to use a semicolon, when to use a comma, when to use parentheses, when to use square brackets. And if you miss any one of those things, the compiler will come back and say your program cannot work. So that class is, is probably more time consuming than this one. The homework assignments will be far more time consuming, because in this class, as long as you have a good understanding of the individual elements of a program, tracing, even a program that looks this long, will take you, if you already know the concepts, it's just a matter of typing, right? And I think most people can do it in half an hour at the most, something like this, once they understand the concepts. But in C++, you have to actually write a program. If you miss one thing in your program, let's say incrementing a counter at the end of a loop, your program is not going to work. So now you have to find out what is wrong with your program from the symptoms, and and that's it can be a very time-consuming process. Where the amount of time it takes to complete a homework assignment can range from a few hours to a few days or more. So I would definitely allocate more time when you take on cisp300 compared to this class. Okay. Any other questions? That's a good question, getting ready for the next class. No other questions? Okay. If there are no other questions, we'll go ahead and continue to have more examples. Last time I talked about the Fibonacci numbers. So what we'll do today is to use that to illustrate the concept of return values, because that one combines quite a number of concepts that we have talked about, and it can look confusing first, but we'll deal with that in a way that hopefully is not confusing. So first of all, we'll go to the definition of Fibonacci. So Fibonacci. It's a good thing that Google knows how to spell check and fix the spellings. If you guys have not made your donation to Wikipedia, I personally urge you to do so. I mean, I pledged $50, and I think I already felt that I cheated the system because I definitely use it a lot more than a $50 textbook. Well, sometimes I also contribute. I actually help to write some of the articles, but not a whole lot. All right. So this is Fibonacci number. That picture is a little distracting. I know most of you are looking at the picture, and that's the human mindset. We are much more attracted to faces. It doesn't have to be like pretty or not, but we just have the innate ability to pay attention to faces rather than boring stuff like squares. They're not exactly squares, they're rectangles. All right, so here is the definition of the Fibonacci numbers. They define f of 0 as 0. They define f of 1 as 1. In other words, these two form the basis of the Fibonacci numbers. They are not defined in terms of other Fibonacci numbers. But anything more than that, if n is 2, 3, and so on, they can become a recursive definition. This tells you f of, let's say, 5. Okay, it tells you f of 5 is f of 4 plus f of 3. Okay, and as such, it is a recursive definition, because if you want to figure out what is the Fibonacci sequence for number 5, you have to first figure out the Fibonacci sequence for number 4 and also number 3. Okay, so now let's go ahead and try to write this up as an algorithm, and then we'll trace it. This one will be a little bit more time consuming, just because there are a little bit more computation. So we'll define sub f for Fibonacci. What kind of parameter do I need here? If you just look at the definition of the Fibonacci number, do we need any parameter? In other words, does the subroutine need a piece of information to do some processing? Yes, it does. How many pieces of information do I need? 2. Just n, 1. We just need 1, because we just need to know, okay, you want to find the Fibonacci number of which, what is the position of that number in the sequence. So we just need 1 piece of information. Okay, so now we know we need 1 parameter. Am I going to change that? Do I need it to be passed by reference, or can I pass it by value?
By value.
We can pass it by value because I have no plans to change that number. It is not like swapping where you have to change the parameters. In this case, we are not changing it. It is input only. It is not input and output. Right? So that means we can say by val n. Okay. Now let's take a look at the definition of the Fibonacci number again, and say we have special cases, don't we? Now this is the general case, but there are special cases where we do not need to invoke Fibonacci or subroutine f again from inside the subroutine. So we have to handle those first. We have to say, oh, if it's the easy ones, we'll handle the easy ones first, and then we'll figure out the complicated one. What type of statement do you think we need in order to handle or separate the branches? A conditional statement. Very good. Okay. So the first one is if n equals to 0. I can test for 1 or 0, it doesn't matter, or even more than 1, but we'll just follow the definition. What should I do when the parameter n is in fact 0? What should I do?
Return 0.
Return 0. Very good, because the Fibonacci number for sequence number 0 is 0. And we'll use a multi-branch conditional statement here. What if n equals to 1? We return a value of 1 because f of 1 equals 1. But what if n yields? Okay, what about this case here? Assuming n is an integer and it is non-negative, what does it imply if I get to this part of the program?
We have to return the invoke statement of Fibonacci for pass n minus 1
To n. And
Plus
then add.
another invoke.
Yep. All right. We can end the conditional statement. We end the subroutine. You have to fix up the indentation a little bit. And by the way, if you take other programming classes, there will be professors who require you to do the proper indentation. In other words, if you turn in a program with the wrong indentation, you can get points deducted because of that. But then there are programs called beautifiers. You can feed it you can feed those programs a improperly formatted program, and the quote-unquote beautifier program will do all the indentations right. It will wrap around all the comments and stuff like that, so it looks professional.
Does an Eclipse do that for you too? Does an Eclipse do that for you too?
There may be a plug-in to Eclipse that can do that. All right. So are there any questions at this point about the subroutine? Because the first thing we want to do is to say, if I have this to do, are we convinced that this subroutine in pseudocode is going to do the same thing? In other words, I am not inventing an algorithm in this case. All I'm doing is to translate the mathematical definition of Fibonacci numbers into pseudocode. Are we doing okay so far? Is everybody convinced? Okay. So now, outside of the subroutine, we just have to say, invoke f. I want to find the Fibonacci sequence or the number corresponding to, which one do you want to do? 4 is going to be a, it will take a long time already. We don't want to do 0 or 1 because that's trivial. 2 is the minimum that will invoke, do the recursion. I think 2 is good. You will see why 2 is already a little bit time consuming already. So we'll use 2, and we'll use 2 to feed to n. And this is the program that I am going to trace today. And this will take a little bit of time because I have to do the explanations at the same time. And should we save this? Oh, single n. All right. There are at least 2 movies that I know of, that has Fibonacci numbers involved. The Da Vinci Code is one, and there's one more that I cannot remember. And no, my password is not, the Fibonacci number sequence.
That would have been my first guess.
All right, so let's go ahead and make this one a little bit smaller because I need more space for the trace for sure. All right. We need comments because there are conditions to evaluate and we have a print statement. We need line number. But the precondition has nothing to say because we do not have any global variables. Now let's go ahead and trace starting on line 11. We want to shrink the columns as much as we can because this will take up a lot of columns. Okay, line 11 is basically the last thing it has to do is to print something. But before we can print something, we have to figure out what is the result of invoking f with 2 as a parameter to n. So we need to set this up. Should we use return line number or should we use return info? Return info because we are not returning to a line, we're returning to the same line to finish what is left to do on that line. So return info is the correct one, and we are returning back to line 11. The print still has to do, it has to print the result of the invocation of f. So are there any questions about how we set up return info in this case? Is that part okay? No questions? Okay. We need one more column because we have a parameter passed by value. Its name is n, and as a passed by value parameter, its initial value is specified by the invoke statement. In this case, it's easy. It's just a constant of 2. So column D starts with a value of 2. Now we have set up the columns. We can go on and continue execution in the subroutine starting on line 3. Line 3 asks, does n equal to 0? The answer is no, it is false that n equals to 0. As a multi-branch conditional statement, we have to go to the next condition on line 5. Line 5 is asking n equals to 1. It's also false because n equals 2. So we cannot go to line 6. Instead, we have to go to line 8, which corresponds to the else. Now here is the part that can get a little bit confusing. Line 8, the last thing you want to do with line 8 is to return, which is to change the question mark in the info, return info cell to a particular value. But I cannot do that yet. Because the second last thing you have to do with line 8 is the addition. I can't do that either because I don't know the operands of the addition operator. I don't know what is the value on the left. I don't know the value on the right of the addition operator. So I can't even do the addition yet. The first thing I have to do is to handle one of the 2 operands, one on the left and one on the right. In this particular case, the compiler, if you use it in C++ or VB and whatnot, there's no particular order in this case. In other words, your program can choose to evaluate the left-hand side first, or it can choose to evaluate the right-hand side first. Because this is not a conjunction, it is not a disjunction, there's no such thing as a short-circuited evaluation, and as a result, the compiler can choose which one to evaluate first. So do not write your program where the order of evaluation is important. But since most of us read from left to right, we'll just follow the same convention and handle the one on the left first. So that means when we execute line 8 the first time, this is the part that I want to deal with first. Is that okay so far? But that's only by convention. Okay. Once we figure out what is the left-hand side of the addition, we'll come back to the same line, and then we'll figure out the right-hand side of the addition. Then we have 2 values. We can actually do the addition itself. Once we have the sum, we can actually perform the return operation. So that's how things needs to be done. All right. So how do we set this up over here? First of all, we are invoking f, so we return info. And which line are we going back to? We're going back to line 8. And this time, we have quite a few things to finish up when we go back to line 8. Now, the most important part is when you specify return info, there should be one and only one question mark in the return info. So that means in this particular case, we'll still have the return. The invocation or the subroutine that we're invoking right now is replaced by a single question mark. The addition is not done yet. and the other invoke is also not done yet. So that has to be spelled out completely.
It's supposed to be -2.
Oh, okay. There we go. Yep.
I'm just wondering, like, can you? I know you can't do them both at once, but could you do it both at once? And like basically. Like,
No, you cannot do it both at once because your computer can only do one operation at a time. It is sequential. So in this case, the right-hand side cannot be evaluated at the same time when the left-hand side is being evaluated.
There can't be like a reset value thing. Like, you know, you go down to you do the first one, then you do the second one. Like you reset. Then you do
This
the
is
second
exactly
one.
how I'm doing it, you know, dealing with one first. And that's why in the return info, the second one is still spelled out the way it is because it is not being handled. It's just, okay, this is something that I have to take care of when I get back to line 8. But we have to handle this one first. Okay? So are there any questions? I mean, is this part okay, that we can only have one and only one question mark when you specify the return info? Yep.
This may be going out of bounds of the scope of the class, but what would happen in the scenario of a multi-threaded application and processor?
In a multi-threaded, you know, environment, you are still writing the program. If you're writing a program like this, then the compiler will have to figure out, you know, can I do both at the same time? And that involves a lot of analysis of the algorithm. In this case, yes, we can do both at the same time. And this is also why you do not want to use global variables, because if the subroutine f involves a global variable, then you cannot do both at the same time, because they can be modified, or they can try to modify the same global variable at the same time, and that can lead to a lot of problems. In this case, you know, each invocation is completely standalone, so yes, in a multi-threading environment, they can split up and perform the operations at the same time. As far as I know, most programming languages, including C++ and Java, does not have any inherent capability to specify, yes, you can do both at the same time, go do both at the same time. So for the most part, with a multi-threaded, you know, programming, you know, with a multi-threaded environment, your program has to be set up explicitly to make use of, you know, the multi-threading capability of the hardware. Yep.
But how does that go backwards? Like, if you have a program that's made for multi-threading, can it just play it as there's only like one core, dual core processor that's made for a quad core? Does it just use the 2 instead of 4?
Well, when you have, you know, if you have only one single core, you can still emulate the other cores. It's just that they cannot do everything at the same time.
Oh, okay.
So you can still say, I'm going to split it into 4 parallel threads, except it can only do one at a time.
Okay.
But when all 4 are done, then you can merge the 4 threads and say, okay, at this point, you know, we can merge all the execution branches back into one single one.
Okay.
So you're basically emulating parallel processing when you do not actually have the hardware to do parallel processing.
Okay.
There are very few applications where parallelism, you know, truly helps. Video encoding is one, you know, where you can separate the screen into multiple portions, and then the encoding of these portions are fairly independent to each other, except for the borders of the regions. So that's one thing. That's why transcribing software typically can make use of multi-core, you know, a multi-core computer effectively.
Each section.
Right. Yeah, but there are very few programs like that. You know, many programs, even if the application can make use of, you know, multi-processing and parallel processing, making the program like that, you know, to make use of that resource, you know, is a little bit of a challenge. I mean, that takes some work. It was until at least a few years after multi-core processors came out that the game engines even started to use multi-core effectively. Yeah, one other application where parallel processing is really helpful is the rendering of graphics on your screen. And that's why, you know, high-end graphics cards typically have hundreds of tiny little processors, each one only responsible to draw 1 pixel at a time on the screen. And that's because they can all be done at the same time.
what about they say like they use the processor to for the graphics. It's not as efficient. They say it's like an actual graphics card. Does that make sense? They said I've read something about that where like
The graphics chip on the Intel Core i5 is not as powerful as a dedicated card like an NVIDIA.
But that has
TI.
but there's a very good reason for that. It's not because Intel cannot design, a powerful processing, chip. It's because of heat dissipation. If you have one single chip that has to do general purpose processing, which is the usual things that a computer has to do, and on top of that you want to have a high-end processor, the chip does not have enough surface area to dissipate the heat generated as a result. A high-end graphics card can easily get up to 250 watts in terms of power consumption, and most of that power is dissipated as heat. So you can kind of think of each high-end graphics card as a 250 watt heater. Okay? The processor, by comparison, even a quad-core processor using the latest process will only consume 90 watts of power. And now you can see, if you combine those two onto the same die, you have a combined energy dissipation requirement of more than 300 watts. Now, 300 watts is a lot of power in terms of heat. It is the same as having 3 100-watt incandescent lamps put together. When you touch an incandescent lamp, it will burn your finger, But this is even worse, because if you think about 3 regular light bulbs, the surface area of 3 regular light bulbs is fairly large compared to the chip, inside the processor. And that's why, we have problems with, including high-end GPUs along with the general purpose one. In fact, for those of you who put your own computers together, you will know that when you try to put in a high-end graphics card, it comes with its own power connector. It is not even distributed through the PCI Express bus. You have to have a special connector to go straight from the power supply unit to the graphics card.
Yeah, mine has 2.
Yours has 2. Okay.
I bought mine just like a couple months ago. And it
Just for the record, my own graphics card in my computer has passive heating. That's the kind of processing power that it has. Just the leftover wind from the rest of the system is enough to cool it down. Because I don't do any type of gaming. All I do is stuff like this. Open up terminals. And log into power. So I don't need that much graphics processing resources.
So when they advance graphics cards, then how does what advance, like you said, the heat? Is it just better when they have like a better graphics card than the generation before? What exactly improves graphics?
They pack more processing power.
Make it more efficient to generate less heat.
Yep.
So less heat, more efficient.
Yeah. In other words, they have MIPS, as a measurement, which is a million of instructions per second. That's MIPS. In graphics card, they have an equivalent, measuring units. I think most of the time it's floating point, so it's called flops, floating point operations per second. That's flops. So but flops is not just the only measurement. You're looking at flops per watt. In other words, for each watt of power dissipated, what is the efficiency of that?
So as it gets more efficient, you get more power out of it.
Exactly. Yep. And it also takes, burns a big hole in your wallet. Like a laser. Oh, there's a big hole right there. Yep.
So, I was reading this one article that they can get, processors they're making, if they keep making them how they are, they can get, possibly as hot as the sun if they do it the way it is. Is that really true? Or
Is it a way to-
Say again?
they can get them as hot as the sun? Is that true?
Say again?
Hot as the sun. Hot as the sun. They can get
As hot as the sun?
Yeah, the way they're making processing, they make them to the point 5 years down the road when they get up to the point where so many processors at once they only fit so much. Do you think that?
I think that might be a problem because cold fusion is even a problem right now. So you're talking about fusion temperature inside your computer case.
Yeah.
I'm not going to have one of those computers. It's going to be sitting in your backyard.
there comes to a point at critical temperature where silicon will actually dissolve. So you'd have to be able to make it at that temperature, and then if you ran it at that temperature and it would melt itself.
All right, so getting back here, we're not done yet, setting up the columns because we are handling this invocation, but this invocation requires its own parameter n. So the question now is, what should I use as this n here? That's the question. Well, let's figure out, what this is really, dealing with. We are on line 8. We are dealing with the left invoke on line 8. We have to pass n minus 1 to n. But this n is not referring to column F. Instead, it is referring to column D. So n has a value of 2. 2 minus 1 is 1. And that's why column F, which is the new column that I'm setting up, has a value of 1. Are there any questions about this? I know this is difficult to see because I don't have enough screen space to see everything. Is that okay? Any questions about this part? Let me see if I can change the display a little bit so that we can.
Instead of left and right, top and bottom.
Yeah. But that will only help a little bit for the first part. Yeah, that's better. And we're dealing with here. Okay, how's that? We are on line 8 the first time. Line 8 has many things to do. It has to deal with the left invoke, it has to deal with the right invoke, then it has to add, and then it can do the return. Before I can do the add and the return, I have to deal with the 2 invokes. But I can only invoke one at a time. So I choose to invoke the left one at first, just because we read from left to right. In other words, I'm handling this part first. I'm invoking F using n minus 1 to specify the new parameter n. And at this point is column D. When I execute line 8, n is still column D. So 2 is n minus 1 is 1, and that's why the next time I invoke, I will use 1 to specify n for that new invocation. The return info is set up this way because I'm handling the left invoke. So the invoke that I'm handling itself is replaced by a single question mark as a placeholder for the return value that at some point I will fill in later. The rest of the line, you can see, is exactly the same as they were on line 8 because those are the remaining operations, pending operations that I have to perform once I come back onto line 8. Is that okay? Okay. So let's continue to move forward. And let me move this one out of the way. It is actually making it less efficient. Okay. So now that we can move on, we have to continue execution in the subroutine that we're invoking, which in this case is subroutine F again, and we continue execution on line 3. Line 3 is asking n equals 0 is false because n is 1 in this case. If that condition is false, we have to go to the second branch and test the condition. N equals 1 is true. So now we can go to line 6 and execute return 1. So here's line 6. Can someone remind me what return does? The return statement, what does it do?
It's going to replace the question mark with
the value that we are.
Value of the line 6.
Very good. Okay, so that means I just take whatever is in return info, copy and paste it, change the question mark to the value that I'm returning, which in this case is 1, and I'm done with line 6. Okay? Do not let the return inside the return info to confuse you. It can be anything. In other words, your return info cell can be line 8, gibberish, 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 question mark, even more gibberish. Don't let it bother you. The gibberish may be a syntax problem, but we don't deal with it now. All you have to do is to locate the question mark, change it to a 1, and you're done. After line 6, we have to go to the end of the subroutine. So if I scroll this down just a little bit, we can see the end defined sub on line 10. So on line 10, what we want to do is to say, well, there are 2 things to do. One is to look up return info and say, oh, okay, Next, we have to go back to line 8. And line 8 will look like this when we get back to line 8. The second thing we have to do is to deallocate these two columns because they are no longer needed at this point. So we'll go ahead and change the format to the strike through. So column E and column F are now deallocated. We have no use of those two columns at this point. And we're back to line 8. Now that we're back to line 8, is there anything else we have to do on line 8?
Yeah.
Line 8 looks like this. I cannot do the addition yet because there's one more invoke that I have to deal with. So we have to invoke F again, and this time use n minus 2 to pass to parameter n, because we're handling the right invoke at this point. All right, well, since we're invoking a subroutine that has a return value, so once again we have to reallocate column E and column F for this invocation. The return info tells me that I have to go back to line 8. The 1 is good, okay? Once we figure out the first invoke has a value of 1, we just keep it. And this time it is our turn. It is time to evaluate the right invoke. And that's why the right invoke is now replaced by a single question mark, because it is just a placeholder for its own return value. The n for the second invoke,
0.
is 0, because it is n minus 2. N at this point is column D, which is 2. 2 minus 2 is 0. Very good. So are there any questions about row 14 of our trace, why we set up the columns this way? Questions? Okay. So now we move on and go to line 3, because every time we invoke a subroutine, we start from the beginning of the subroutine that we are invoking. Line 3 is doing the same thing. N equals 0 is the first thing it evaluates, and that's true because n as a parameter has a value of 0. We go to line 4. Line 4 says we want to execute return 0. Once again, what you need to do is to locate your return info cell, copy and paste it. It should have one and only one question mark. Change that to the value that you're returning, and you're done. Okay? Do not, at this point, do not say, oh, okay, so I know exactly what we're supposed to return now. 1 plus 0 is 1. Don't even do that. Your only job when you execute a return statement is just to change the question mark to the value that you're returning. Leave the rest of the return info cell alone. Okay? After line 4, we get out of the conditional statement. We end up on line 10. Line 10, once again, has two things to do. One is to say, oh, we have to continue execution on line 8 after this subroutine is done. And line 8 now looks like this. The second thing it has to do is to deallocate the two columns. And now we are back to line 8. Line 8 now looks like this. Return 1 plus 0. Do I have any additional invokes to deal with on line 8? There's no more invoke. Can I compute 1 plus 0?
Yes.
It's 1. So this is now just returning 1. I can actually execute line 8 as return 1 at this point. Well, that means I have to locate a return info cell, copy and paste it, and change the question mark to 0. Well, this is why it's a little bit harder to see because it is way up here. So we take this one, we copy and paste it, and we change the question mark to return to 1 plus 0, which is 1. And we are done with the return statement on line 8. After line 8, we go to line 10, which is the end of the entire subroutine. At this point, I have two things to do. One is to remind myself. Next, we have to go to line 11 because we have the print still pending. And the second thing we have to do is to deallocate the two columns for this invocation. And now we are continuing on line 11. But line 11 now looks like this. We're just printing a constant of 1. Sure, we can do that. You just say print 1. It may be printing to the screen, maybe printing to the printer, maybe printing to the network. We don't know where it's printing to. Doesn't matter. And we're done. Okay. So this is a good illustration because not only do we have recursion, And not only do we have an invoke in the same statement as a return, but we have two invokes. And it's not any more complicated than the examples that we have before. You just have to deal with one invoke at a time. When everything is resolved, then you can finally execute the actual return statement, where you will find the return info cell, copy and paste it, change the question mark to the value that you're returning, and you're done. Are we doing okay so far with the Fibonacci number? Okay. If I maximize this screen, it doesn't look too bad. Okay, it doesn't look like we're using a lot of columns, and it's not using a lot of rows in the trace. What do you think happens when I try to figure out the Fibonacci number, the Fibonacci value of 3 instead of 2?
It's going to increase it twice that size.
It'll be twice that size, exactly. Okay, and that's why I picked a relatively small number, because otherwise we'll be doing this until the end of this class period. If any one of you want to do that, just do it as your own personal exercise. Instead of trying to find the Fibonacci value of 2, you try 3. And you will see that it is exponential. Okay, the number of rows you need to trace this is exponential to n. Yep.
So you need 9 rows, you're saying, for 3?
For 3, you need twice the number of rows here. I would say it's about 40.
Oh, okay, I got you.
It's a little more than 40.
No.
Because it's doubling every single time. When you add 1 to n, you're doubling the number of rows that you need. Well, about. So are there any other questions with subroutines? No other questions with subroutines? Let me make sure we save this one. And now we are moving on to a new topic. So we finally get to records, which is a very important topic. Uh-oh. There we go. Okay, so we are now moving on to topic 10. So I'm going to change the highlight to topic 10. Yep.
You say we should read the things, and I understand, but it is very hard for me to understand. Like when I read it, I do get somewhat confused. Like I understand vaguely, but like I really need it in
That's
class.
okay. But at least you try to read it. If you have some pre-exposure before the class, it still helps. So that's why I said, don't bang your head, if you don't fully understand what I write. But at least read a little bit ahead of me so that you know what is coming, what kind of topic is coming. Okay, so topic 10 deals with types and records. We probably won't have time to get on to object-oriented programming, which is closely related to types and records. Okay, types and records there are 2 aspects to it. One is what is a type, and then the second one is what is a record. But they are closely related to each other. Let's deal with records first. Okay, I'm changing the order compared to the presentation in the notes. Let's talk about records first. We don't usually fill in forms anymore, like paper type of forms, but some of us still has to do that once in a while. So let's just take our let's say student enrollment form or student registration form as an example. Okay, when you first become a Los Rios student, you have to go through the registration process, and as a result, you have to fill in some forms, give out a bunch of information. So what kind of information do you have to fill in that form? What kind of fields do we have in that form? We have given name, first name, and then we have family name or last name, and then we have the middle initial. We have usually they will ask for your birth date. Okay, so we have birth date. They will ask for your address. And your address all by itself has multiple components, because you have your street number, you have your city, state, zip code, and then you have your phone number, and so on. I mean, the list just goes on and on and on. And if you're not doing this online, instead you're doing this on a piece of paper, what does that piece of paper look like? Well, it's going to be quite dense because there's a lot of information. So, it is formatted to include, different fields of information, kind of like this, right? What if I tell you, we don't want to do things this way anymore? Instead of giving you a single sheet of paper that has multiple items to fill in, I'm going to give you a pile of little slips of paper. On each slip of paper, the first one, you have to fill in your first name. On the second slip of paper, you have to fill in your last name. On the third slip of paper, you fill in your middle initial, and so on. So now, instead of one single sheet of paper, it has a lot of stuff on it, but it's still a single sheet or maybe a pile. You now have a big pile of little slips of paper. Okay, so keep that in your mind. Yep, go ahead.
All right, so, okay.
Because I want to explain why we need the concept of a record.
So those are the records, each slip of paper?
No, this is a record. Each slip of paper is a variable that we come to know at this point. Okay? So now you're walking around, you fill in your form, you have your own big pile of little slips of paper, and you're just walking around and you run into somebody who also, had to fill in these forms, and you guys, threw, all these little slips of paper around, and they're all mixed up on the floor. What are you going to do next?
Fight?
No. You might end up with the last name of somebody else. Your address may be mixed up so that you picked up your correct street number, you picked up the correct city, and then picked up the other person's street, and maybe the other person's zip code. Okay, so you can imagine all the mix-ups that can happen when you have this big pile of little slips of paper, and each person has its own pile, and then mix-ups is bound to happen. And that's what we have when we have individual variable. Each individual variable is a little slip of paper. It can only contain one piece of information each. In order to represent a student record, now you need a whole bunch of individual variables. Are we doing okay so far? Mapping, the physical analogy to the programming concepts that we know at this point. And just like, the example, what if you bumped into somebody else, and you both, threw all the slips of paper on the floor? It's just like that in programming. When you have two records to process, let's say, let's say you're cross-checking something between two records. If you have to pass 30 parameters to represent the first person and 30 parameters to represent the second person, just imagine inside the subroutine when you have to refer to individual pieces of item from each person, it is very easy to have a mix-up. Because now you have 60 variables, and you have to keep track of which name or which parameter name corresponds to which person that you're representing when you invoke the subroutine. Okay? So yes, you can do it. You can do everything without records, but it certainly makes things a lot harder because it's much easier to make mistakes. So when we look at record as a concept, it's nothing more than a packaging concept. It is just saying, instead of having slips of paper, 30 little slips of paper, let's design a form like this. Okay? On each sheet of paper represents a student record. So now you can have, when you want to process these forms, you can have two forms, and then you can easily refer to, the name of the first form, the name of the second form. The address of the first form, the address of the second form. So now you have a choice. When you pass it as a parameter, all you're doing is you're giving the subroutine two forms. That's it. From the perspective of the invoke statement, there are only two items. But inside the subroutine, if the subroutine needs to, it can say, I need to look at a specific item in the first form. I need to look at the first name of the first form. It can choose to do that when it needs to. Yep, go ahead.
So you said the sheet of paper is a record, so each little thing, the birth date would be the type, and there would be a type on
It is
each
called a
record?
field or a component or property or an attribute of the record.
Okay.
Okay? So let's go ahead and write, some programs related to this. So we'll deal with something that is a little bit easier to understand first, and then we'll see whether we have time to increase the complexity. So since we're dealing with records, it makes sense that the construct would start with the word record. And in this case, I don't want to deal with something too complex. Let's see how we can represent a date in human readable format. Okay? How do you guys represent, date and time? Typically, we have year, month, and day for a date. So we'll go ahead and say record date, because we're defining a record type called date. And inside we have three little pieces of information. We have year, which is an integer. We have month, as an integer. And then we have day of month, also as an integer. And record. So now we're encountering the concept of a type. We haven't really used the colon representation at this point to say that this is an integer or that is a Boolean and so on. But at this point, I think it's a good time to introduce the concept of a type. What a type is a restriction. And the best way to illustrate it is to illustrate what happens when we do not have types. I think we want mouse pad. There we go. Okay. What is the result of that? Is it computable?
Yes.
It's computable. It is 36. 46, correct. 36. 46. Okay. It is a value, okay? It's a value. Okay, fine. Okay, my arithmetic is bad. Okay, but it makes sense, okay? The operator makes sense because when you have an addition, okay, look from the perspective of the addition operator. Do you think it has expectations of the left-hand side and the right-hand side? Yes. Okay, what kind of expectations do you think an operator, a plus operator, can expect?
Numbers.
They have to be numerical values, okay? They can be integers, they can be real numbers, they can be rational numbers, they can be irrational numbers, but it has to be some kind of numeric value so you can add them together. Now let's take a look at the second one, and you tell me what it means. 12 and 36. Go ahead.
We don't know.
We don't know because as a conjunction operator, what do you expect on your left and the right-hand side?
Booleans.
You expect Booleans, okay? Booleans means, they can be true, false. And yet, we have 12, which is not true, false. We have 36, which is not true, false. In other words, this does not make any sense. Okay? And this is why we have types. Because what we are dealing with here is when you define operators like AND, addition, subtraction, multiplication, and so on, each operator has a constraint of the types on its left-hand side and its right-hand side. In the case of AND, it is expecting both sides to be Booleans, true, false values. When you're dealing with addition, it's expecting both sides to be numerical values. It's the same thing with comparison. Okay? It makes sense to evaluate something like this. Okay? Now remember, this is false, okay? Because we are asking the question, is it true or is it false that 12 is less than 4? We can come up with an answer, that's not a problem. But this is a problem because true and false cannot be compared. Okay? One is not greater than or less than the other. You can compare like this. Is false equal to false? That makes sense. Are they the same? But other than whether they are the same, you cannot say whether one is greater than the other one. So once again, it is the expectation of the operator. I can only do it on certain things. Yep.
False equals false is true. That would be the whole sentence.
Correct.
No.
False equals false is true. That is correct because they are the same. Okay? And that's why we have types. Now, all the types that we have talked about or used in this class, the one that we use the most is the integer type. The integer type basically says you can represent negative values, positive values, and 0, but they all have to be whole numbers. They cannot be fractional. In this class, we also deal with Booleans, which means each one can either represent true or false. Those are the only two types that we have dealt with at this point. So getting back to our example, this is our record date. And what we'll do is we'll just have a simple, very simple example, and we'll just say define sub XYZ. We'll just call the subroutine XYZ. It has a local variable, and this time we define the local variable as date of birth, and it has a type of date. And the subroutine will do something not so smart. All it has to do is to say we'll change the year of that to be, oops, used the wrong operator. But let's say we're processing something for today. So this is a newborn baby, and the month is December.
Say the year again.
Oh. And the date is today, which is the 6th. Obviously, the subroutine really does not do anything useful because everything is being done to a local variable. But that part is not really the point of this illustration. We want to see how everything is represented. So right away, we have a few questions. Because the question is, what exactly is date on line 1? And what exactly is DOB, date of birth, on line 7? Okay, that's the first question. And the answer to that is easy, especially if you like cookies. Date is the name of a cookie cutter. From line 1 to line 5, all I'm doing is twisting the sheet metal to make a cookie cutter. And I call that cookie cutter date with an uppercase D. Is that okay so far? In other words, I'm defining a factory, a template, a blank form, if you will, and I say that every date object is going to have 3 attributes. The first one is a year. It has to be an integer. The second one is a month. It has to be an integer. And the last one is day of month, which also has to be an integer. But it's a cookie cutter. It simply says the cookie has a particular shape. When we get to line 7, DOB is a cookie. In other words, we are using the cookie cutter that we called date, and we take cookie dough, which in our case is our columns. Okay, we take our columns, and then we take our cookie cutter, and we go like that, and now we stamp out the cookie. It has the shape of a date. It has the 3 things inside. And at this point, we don't know those particular values, but it has those 3 things. Okay? In other words, when you execute this program, line 1 to line 5 does not use up any cookie dough. You can write a program with 20 gazillion record definitions. All you're doing is to define cookie cutters. When you run the program, the only time we need any dough is when we get to the subroutine, when we need to instantiate or make that local variable DOB. Yep, go ahead.
So 6 through 11 is the dough here, you're saying?
No, line 6 to line 11 require actual dough because we are making a cookie out of the cookie cutter. We are stamping out a cookie.
That would be the input you put in.
Well, in this case, it's hard coded.
Right. Okay.
Yeah, but that's. In other words, this program serves no other purpose than just to illustrate the concept of records, record types, and variables that you can make out of these record types. Okay, so let's go ahead and trace this program and see what happens. What happens to the columns, how do we name the columns, and so on and so forth. So right away, we are actually talking about object-oriented concepts already. It's just that we have different names in the object-oriented programming paradigm. We just have different names for these things. We don't call them cookie cutters and cookie dough. We just call them something else. You can see, programming is really quite easy.
Once you have the logic.
Once you have the logic and you can map everything to things that you can touch, and in this case, eat. All right. So there's nothing to say about the precondition. We have no global variables. The only line that is outside of the definition of a subroutine is line 12. All it does is to invoke the subroutine XYZ. In this case, return line number would be fine because it does not return a value. So there's no need to use return info, which is more complicated. And it does not have any parameters either. So all we have to say is to say after subroutine XYZ, we are pretty much done. Then we continue execution on line 8. Oh, but hold on a second. We do have a local variable. Look at line 7. It says DOB is a local variable. So just like with your other local variable, you have to allocate columns for it. Except this time, DOB has components. It does not take up one single column. It takes up 3 columns because it has 3 individual pieces of information to store. The first one is year, the second one is month, and the last one is DOM, day of month. So if I have to make this more obvious, I would merge columns D, E, and F, and collectively they become the local variable DOB. Even though it has 3 individual components, I can sometimes refer to the whole thing as one single thing. Is that okay? So in this case, this is our cookie dough. Okay? CPAP. That's my recommendation. I had to return my CPAP test machine, so now I have at least 2 weeks without a CPAP. So I'll be doing that at home. My kid says, it's loud enough that they could hear me, across a long hallway with the doors closed. Yep.
I don't mean to keep asking questions.
No, that's good.
On the on 8, 9, and 10, can you further restrict the integers within a range?
Not with most programming languages. There are only certain programming languages like Pascal and Ada that allows you to specify a sub-range when you specify integer.
Oh, really?
But most practical modern programming languages do not allow you to specify a range.
It'll just happen because you never go past 12 for the month or whatever.
Right, I cannot express that with most programming languages. I know what you're saying. It makes sense that sometimes you might want to restrict a range, but most programming languages do not let you do that.
Okay.
But can you restrict how many digits? Can you restrict how many digits?
In some cases, yes, it can be implied. You can have a 32-bit integer, 16-bit integers, and so on. Yep. Now, as with all local variables, you have to say, oh, but what are the initial values for each chunk of that cookie? In this case, it's unknown, okay? Because we have not had a chance to specify the content of each column. We are just saying, okay, make a cookie out of this cookie dough, but we don't know whether it has chocolate chips or peanut butter and whatnot. Yep.
You could relate records to a cousin of an array.
That would be kind of strange in a way because that's a very good thing. Let me clarify that later. But it's a good thing that you bring that up. Okay, but let's finish this program first. We are going to execute this program on line 8. Line 8 says we want to change something in DOB, but we are not changing the entire DOB. If I say DOB and then the left arrow and then the value, it doesn't make any sense because it has 3 components. So which component do you want to change? So I have to say exactly which component I'm changing. In this case, I'm changing the component called year. So year is now named 2011. or has a value of 2011, and line 9 is changing the month to 12, and line 10 is changing day of month to 6. Are we okay with this? And on line 11, I just make the whole make the whole subroutine useless, because I'm going to deallocate all columns. And remember that we have to get back to post. There we go. Okay, so you are absolutely right that it looks like we have something that is kind of like an array, because remember, if you look at DOB, doesn't it look kind of like an array with 3 elements? Except we don't name the elements, or the individual items, bracket 0, bracket 1, and bracket 2. But that's a major difference, okay? There are several major differences between an array and a record. The first one is, in order to access the individual items, with an array, you use the square bracket notation. You use a number to specify which part of the array do you want to access. And the nice thing is that number can be an expression. So you can change that expression, or you can change the value of the expression during runtime. When you're dealing with records, you are calling out, or you are trying to address each item by its name, which means you cannot say, sometimes I want to use year and sometimes I want to use month. That you cannot change at runtime. Okay? Now, even more importantly, year, month, and day of month, they do not have to have the same type. In an array, every single item, every element in an array must be of the same type. They must be very uniform. But in a record, you can mix and match. You can have, this is a number, this is text, this is Boolean, and so on and so forth. You can mix and match any way you want. You can even have other records as a type, as the type of a component of another type. So you can nest these things, which makes it very useful. Okay? So now, one last thing. I know we are running a little bit over time. The last thing is, well, how does this map to object-oriented programming concepts? Because you are going to cisp300, which is the beginning object-oriented programming class. Your teacher is not going to talk about cookie. There's no cookie dough, and there's no cookie cutter. The cookie cutter, in this case called date, is also called a class in object-oriented programming. The cookie that has a name of DOB in this case, something that you cut out using the cookie cutter, is called an object in object-oriented programming. So now you have class, you have object, and those are the most important 2 terms in object-oriented programming. Okay? So read ahead of me. We still have Thursday. This Thursday we have a practice exam. When is our exam? Final exam?
Thursday.
Next Thursday. So on Thursday we'll have a practice final exam. So I'll give you a few questions to work on.
Can we come to class next Tuesday?
No, there's no.
I'm not supposed to.
I think next Tuesday is the last day of instruction, so I think there is class.
No, there's not.
There's no class?
Thursday's the last day of instruction.
This Thursday's the last
Friday's
day.
the
This
first day of
Thursday?
finals.
Friday, well, Saturday.
Oh, okay. So there won't be any class next Tuesday.
Friday's the first day of finals. We have a Friday.
Okay. Well, the whole semester just passes by like that.
Yeah.
There goes another one.
All right. Let me save all this down. Stop the recording.
Monday.
At least you can roll me.
Did you pass?